I really, in this video, want to do some review on type 1, type 2 error, as well as one proportion z-tests, and show you kind of a real-life example of a one proportion z-test from Minnesota. The Tour de France tests athletes for elevated blood oxygen levels compared to earlier tests for the athlete. The null: the athlete is not using a substance to raise their blood oxygen level. The alternative: the athlete is using a substance to raise their blood oxygen level. In context, describe type 1 and type 2 error. Remember, type 1 error is rejecting the null when the null is true. So if I reject the null, I say they are using a substance, but in fact they're not. So there's your type 1 error. We think the athlete is using a substance, but they are in fact not using it. Okay? So that's type 1. Type 2 error, if you'll recall, is failure to reject the null, when in fact the null is true. So if I fail to reject it, I say they're not using, but in fact I should have rejected, meaning they were using. So there's your type 2 error, right? Because you failed to reject, meaning you don't think they're using, but you should have rejected, meaning they were. Okay, so we don't think the athlete is using a substance, but they are. Let's do a little more work with this context. An athlete once said of the Tour de France that 90% of all bikers were using while competing. With better testing, a simple random sample was taken of 120 bikers and tested. If 102 of the 120 samples show evidence of juicing, is there evidence at the 0.01 level against the athlete's claim? So, we are going to state the null, of course, is that P is equal to 0.9. The alternative, in this case, it didn't really say above or below. 102 out of 120 is 0.85, but it just said, is there evidence against the claim of 90? I'm going to actually run this as a not equal to. P is the proportion of bikers juicing or using that banned substance. Okay? Plan. Well, it's a proportion problem. So we had a simple random sample. That's good. 120 is less than or equal to 1/10 all the Tour de France bikers. 120 multiplied by 0.9, that claim from the null. Please remember, don't use the p hat here. And 1 minus 0.9, this is 108. This is 12. Both of those are larger than 10, so we can proceed. The do. Well, we're going to do a one proportion z test. Okay, you can state this either in the plan or right here, but we should state what test we're doing at some point. Because we're using our calculator, we should at least say what we're doing. So here I went to the one proportion z-test in the calculator. We're testing the null claim of 0.9, 102 out of 120, and the alternative is a not equal to. So I hit draw. I get this when I hit draw. So what I should report in this do portion, remember, is your test statistic, which for me was a z of 1.83, I guess, and a p-value of 0.0679. So now we can conclude. Against the 0.01 level, we will fail to reject the null. Remember, we should say why. We should say something about our p-value being, greater than, and you could even say your p-value is, above the significance level that we're talking about, that 0.01. And then we should put that in context. You see, I've put that right here. If we have failed to reject, that means we're back here. We said, okay, so we're still at 0.9, so we don't have evidence to say that that athlete's claim is false. Okay, I really just wanted to show this because it took place in Minnesota. It had to do with a pork plant in Austin. So we have this condition, and you could certainly pause this and read a little bit more carefully, but a inflammatory, CIDP, it struck this plant, these people in this plant, at a rate that seemed too big, too much. So you can see this kind of neurological condition normally strikes 2 per 100,000 people, but in this plant it struck 11 out of 100. So testing this kind of null of, well, the proportion should be 2 out of 100,000, and of course 11 out of 100, we see that it seems to be way bigger than that. Without doing the whole test, I just wanted to show you what the outcome on the calculator was and what the p-value was, and explain then how these kinds of things are used in situations like this or in lawsuits. Okay, so let me drag in my actual work for this. So I did a 1 proportion z-test, 2 over 100,000, 11 out of 100, I did greater than, so you can see the results here. A z-statistic, and if you remember, the meaning of z is it's how many deviations away from the mean are you. 245 deviations, which the calculator rounds to a p-value of 0. So we would obviously reject the null, meaning in this plant we have evidence that the rate is much higher than it should have been, and very significant evidence, being as the p-value was 0. So again, this is how, medically we look at things and say, well, this should never have happened. 11 out of 100 people should never have happened. Something is wrong with this plant. And then this is how lawsuits begin to get generated, that we have some evidence, we could call in statisticians to say something in this plant has caused this, maybe the company was negligent, and this is how, civil lawsuits kind of get rolling from a statistics standpoint. And again, all using the 1 proportion z-test that we already know.